my name is Sudip Tamang from section DC6. I'm here to give a short presentation on the topic of genetic algorithm. Before starting, let's see agendas of this presentation, what are the parts that I'm covering of genetic algorithm. First one is in this presentation I will be talking about the general introduction of genetic algorithm. Then after, problem definition, history of genetic algorithm, pseudocode, time complexity analysis, and the application of genetic algorithm, some limitations, and at last conclusion of genetic algorithm. So, introduction of genetic algorithm. Genetic algorithm is a type of algorithm which belongs to evolutionary algorithm. It is an adaptive heuristic search algorithm. Why it is an adaptive? Because if there is an algorithm, it is adaptive with respect to the number of parameters that you are giving to the algorithm. By this way, its nature is adaptive. For instance, this algorithm adapts with respect to the change in the environment. Nature has always been a great source of inspiration to all mankind. This algorithm is basically on genetic and natural selection. It is used to generate high quality solution for optimization problem, which means if we are given a search problem or optimization problem, in that case, if we need to find the best solution or global optimal solution, then we must adapt for genetic algorithm. Next, we have a problem definition of genetic algorithm. Problem which appears to be particularly appropriate for solution by genetic algorithm include timetabling, scheduling problem, and many scheduling software packages are based on genetic algorithms. Genetic algorithms have also been applied to engineering. Genetic algorithms are often applied as an approach to solve global optimization problem. As a general rule of thumb, genetic algorithm might be useful in problem domain that have a complexity fitness landscape. As a recommendation is designed to move the population away from local optima that a traditional hill climbing algorithm might get stuck in. Next, we have history. Like as early as 1962, John Holland's work on adaptive system laid the foundation for later development of genetic algorithm. By the 1975, the publication of the book Adaptation in Nature and Artificial System by Holland and his student and colleague. Early to the mid 1980s, genetic algorithms were being applied to a broad range of subjects. In 1992, John Koza has used genetic algorithm to evolve program to perform certain tasks. He called his method genetic programming. Next, we have like basic terminology used in genetic algorithm. It's population. It is a subset of all the possible encoded solution to the given problem. Chromosomes. Chromosomes is one such solution to the given problem. And gene. A gene is a element position of a chromosomes. Allele is the value gene taken from a particular chromosomes. So talking about the pseudocode, talking of the pseudocode, it start with the generate the initial population, compute fitness, and repeat all the process like selection, crossover, mutation, and computation fitness until population has converge stop. So talking about the selection, the idea of selection phase is to select the fittest individual and let them pass their gene to the next generation. Crossover is the most significant phase in a genetic algorithm. For each pair of parents to be mated, a crossover point is chosen at random from within the gene, and mutation occurs to maintain diversity within the population and prevent premature coverage. And next we have time complexity. Genetic algorithms are not characteristic, they are stochastic. The complexity depends on genetic operators, their implementation, which may have a very significant effect on overall complexity, the representation of individual and the population, and obviously on the fitness function. Given the usual choice point mutation on point crossover routelet wheel selection, genetic algorithm complexity is big O of G n plus n, with G the number of generations and the population size, m the size of the individuals. Therefore the complexity is on the order of G n m, the big O of G n m. This is of course ignoring the fitness function, which depends on the application. So next on is the application of genetic algorithm. Genetic algorithm is being used in various fields like genetic algorithm in robotics. Robotics is one of the most talked field in the computer industry today, and it is used in wide range of industry in order to increase efficiency and accuracy. As the environment in which robots work change with time, it becomes extremely difficult for programmers to figure out every possible behavior of the robot in order to cope with the changes. It is here where genetic algorithm plays a critical role. Hence a suitable approach is needed which will lead the robot to its goal and will make it adapt to new situations as it encounters them. Genetic algorithms are adaptive search techniques which are used to learn high performance knowledge structure. Genetic algorithm makes parallel search of the solution space through a population of candidate solution, and the population is manipulated in the simulation. The candidate solution represent every possible behavior of the robot, and based on the overall performance of the candidates, each could be assigned a fitness value. Genetic operators are then used to improve the behavior of the population. Next we have next area is genetic algorithm in the financial planning. Models for tactical asset allocation and international equality strategies have been improved with the use of genetic algorithm. Genetic algorithms are very efficient for financial modeling applications as they are driven by payoff, which can be used to improve accuracy of prediction and return over the benchmark set. Moreover, these methods are robust, allowing a greater range of extension and constraint which may be accommodated in the traditional method. And next application is genetic algorithm in code breaking. Genetic algorithms can be used to search a large range of solution of cipher and at last TSP and sequencing scheduling. And the traveling salesman problem is a particular problem where genetic algorithm has known to provide accurate solution with high computational efficiency. So next we have limitations of genetic algorithm. Though genetic algorithm has provided to be a fast and powerful problem solving approach, some limitations are found embedded in it. Some of these limitations are like the first and the most important consideration in creating a genetic algorithm is defining a representation for the problem. The language used to specify candidate solution must be robust, that is, it must be able to tolerate random change such that fatal error do not result. One major obstacle of genetic algorithm is the coding of the fitness evolution function so that a higher fitness can be attained and better solution for the problem at hand are produced. A wrong choice of the fitness function may lead to a critical problem such as unable to find the solution to a problem, or even worse, returning a wrong solution to the problem. Along with making a good choices of fitness function, the other parameters of genetic algorithms like population size, mutation, and crossover rate must also be chosen with care. A small population size will not give the genetic algorithm enough solution space to produce accurate result. A high frequency of genetic changes or poor selection scheme will result in distributing the beneficial schema, and the population may enter error catastrophe, changing too fast for the selection to ever bring about convergence. And it is not advisable to use genetic algorithm for analytical problem, though genetic algorithm can find accurate solution to this kind of problems. Traditional analytical method can be find the same solution in less time with few computational steps. And premature convergence is another issue genetic algorithm scientists need to take into account. When solutions of genetic algorithm are generated, it may happen that an individual can be much more fit than any of its competitors. So this individual may reproduce many more new individuals, reducing diversity of the new population and leading the algorithm to converge of the local optimum that represent the particular individual, rather than searching the fitness landscape through enough to find the global optimum. This kind of inefficiency is mostly seen in small problem where even chance variation in reproduction rate may cause one genotype to become dominant over others. So at last, in conclusion, evolutionary algorithms have been around since the early 60s. They apply the rules of nature evolution through selection of the fittest individual, the individual representing solution to the mathematical problem. Therefore, in conclusion, genetic algorithms are so far in general the best and the most robust kind of evolutionary algorithm. Thank you.